There is a quadratic function y is equal to 1 over 4 times x minus 4 squared. A is a value from regular octagon dice. Solve for the possibility minus 1 over 2x plus a passes through the segment AB. Let's think about the two cases in our quadratic function. And both of the cases were going to be defined by our leading coefficient, which we usually notated as a. And the first case will going to be when the a value, our leading coefficient, is greater than 0. Which means when our leading coefficient is greater than 0, the positive value, the graph of our quadratic function will open or will go upward. When the quadratic function goes upward, for example, it will look something like this that keeps going toward upward and never intersects at specific one point, but then it will going to contain one point that is one of the most important thing in the quadratic function, which we usually notated or called it as minimum, or the lowest point on the quadratic function, and this will occur when the a value is greater than 0. And the second case of our quadratic function will going to be the case where our a value, our leading coefficient, is less than 0. Which means when our a value is negative value, the graph of our quadratic function will open or will go downward. When the quadratic function's graph goes downward, for example, it will look something like this that keeps going toward downward and never intersects at specific one point, but then you're going to contain one point, which is another most important thing in the quadratic function, which we refer to as the maximum point or the highest point on our quadratic function. And this will occur when the a value, our leading coefficient, is less than 0. Now if you think about what the vertex of any function, especially when the quadratic function, we're going to be the addition of the number of possibilities between the minimum point and the maximum point. And if you think about what the vertex will going to be, again, it will be the addition of the number of possibilities of the minimum and the maximum point. Which means minimum and the vertex, or minimum or the maximum point, will going to be the vertex. But then vertex has the two different cases where the a is greater than 0 or less than 0. In order to solve for the a value, which is the number of possibility from the octagon dice, first of all, we need to solve for our segment AB. In order to solve for the segment AB, we need to know the coordinate of A and B. So first of all, let's think about what the coordinate A will going to be. So for the coordinate A, as we can see, it is on the y-intercept. And now if you think about what the y-intercept will going to be, y-intercept will going to be when it converts this into a coordinate, it will going to be 0, comma y, where our x value is equal to 0, and our y value is equal to something and exists. And if you think about this in the more specific function, we can see that the y-intercept will going to be the case where our input a specific function is equal to 0, and our output of our function exists, which we noted in this case as y. So this will going to be what the y-intercept will going to be. So y-intercept will be when the input, which we notated as x, is equal to 0, and the y value, which will going to be our output, exists. Now let's think about what the point B will going to be. If you think about B, only thing that is different with A is our x-intercept, x value. The reason is because for the B value, if it's same with A, we'll locate right over here. But then we moved to the vertical way, which made our x value different with the A value. So that's why the B value will going to be x, comma y, which will going to be our normal coordinate. But then our y value, which will going to be our output of our function, should be same with the a value, and the input of our function, which we notated as x, will going to be different. Let's actually solve for the coordinate. So the a value will going to be the case where our x value is equal to 0 and our y value exists. So all you have to do in order to find our y value is simply input our x value into 0. If we input our x value as 0, it will turn into y is equal to 1/4 times 0 minus 4 squared. In order to solve for the y value, which will going to be our output of our function, all you have to do is simplify this function. So 0 minus 4 will going to be -4. Square will turn into 16 times 1/4 will turn into 4. So we can simply say that our point A will turn into 0, 4. If we explain this, we're going to be when our input of the function is equal to 0, then our output of our function, which we're going to call it as the y value, will turn into 4. This is what the 0, 4 is. But then let's think about what the b will turn into. If we convert x, y, but instead of y, as we have think about it, the y value is exactly the same with the a value, but only thing that is different will going to be the x input value. So we can replace it, the y value as 4, since we knew that our a value's coordinate will going to be 0, 4. So now all you have to do is we can simply input our y value as 4 and get an input of our function. The reason why we could solve a and b is because a and b are the point that rely on our quadratic function. And the reason also why we could say that the b value is exactly same with the a value's y value is because the properties in our quadratic functions. And if you think about what our properties of our quadratic function will going to be, the points that rely on that looks exactly same or the parallel will going to be congruent, which means they're all same. So in this property, you could solve for a and b. So if you input x value as something, but then we don't know it, so we can simply input our y value as 4 here. And we're going to get 4 is equal to 1/4 times x minus 4 squared. And now in order to solve for our x value, all you have to do is we can multiply 4 to the both sides in order to isolate our x terms. If we do it, it will going to turn 16 is equal to x minus 4 squared. But then there will going to be two cases. So the two cases will going to be the case. So the two cases will going to be the case where our x value is equal to negative value, or the y value which will going to be our output function is equal to the positive value. So we need to think about our number of possibilities. But then, as you have told, the most important thing or the most convenient way in order to check out or prove this into visual way. So in order to prove this into visual way, all you have to do is we need to check our graph. So point B, the y value is also the positive value, and our x value is also the positive value. So we can only think about our x value is not y value, it should be the x value as the positive value. So we can simply cancel out the negative value. Now all you have to do is we need to take square root to the both sides in order to isolate our x terms and remove our square. If you do it, you will gonna turn into square root. So square root of 16 is equal to x minus 4. Square root of 16 will easily turn into 4, as we knew that it is a perfect square. But then it will going to be equal to x minus 8. All you have to do in order to isolate our x term is add 8 to the both sides. And we can simply get our x value as x is equal to 8 plus 4, which will turn into But we got a mistake here that it's not x minus 8. It should be x minus 4. So we can actually write it down again. Square root of 16 will turn into 4. It is equal to x minus 4. All you have to do in order to solve for our x value, we're going to be adding 4 to the whole size in order to make the Gibbs equal value. And set the x value isolated into one side. If we simplify this, we can get x, we're going to be 8. So we got the coordinates. So for the a coordinate, which was our y-intercept, we're going to be 0, 4, where if our x value is equal to 0, our y value is equal to 4. And for our b value, which was the coordinate that contains same y-intercepts, same y coordinate as the x, a, but different x coordinates. So we're going to be 4, 8. So we found two coordinates of a and b, which was the way to solve the lengths of our segment a and b. And if you think about the lengths on the coordinate plane, will going to be the difference. Between the coordinates. So the lengths on our quadrant or the coordinate plane will going to be difference between or 2 or 3 coordinates. So this will going to be what the lengths on the coordinate plane will going to be. So if you think about the difference between our a value and the b value, which we're going to make the segment AB. So if you think about the y value, which will going to be our imperative function, there is no difference. But if you think about a and b, there are differences, which can be either 8 or negative 8. But if you think about the lengths of something, we can't think about it in the negative value, because there is no such negative thing in our coordinate or the segment. So we always need to think about the lengths in the positive value. So we could say that the positive 8 will going to be the length of our AB. So this segment AB will going to be 8. According to the information that they gave us, for the y is equal to negative 1/2x plus a, which will going to be a linear function, which means if we convert this into a coordinate plane or the graph, this will going to be a straight line. So that means this one passes through our segment AB. But then we're trying to find the value of the a, which makes this whole expression the same. So at first, let's write our function, linear function down, which will going to be y is equal to negative 1/2x plus a. And we could see that this function will going to be the linear function, which means the function that has the first power degree term of our variable, and it will going to be dx. In this case, we're trying to find the value of the a, which will going to be the unknown variable. So the a value is unknown. And the one clue that they gave us is that the a value is from the dice regular octahedron. And if you think about what the regular octahedron dice will going to be, it will going to be the 8-sided dice. And the a value is one of the 8-sided dice, which means we can think about the number of possibilities in our a value. So it can be either 1 out of the 8 value, which we're going to make our number possibility 1/8. So 1/8 will going to be the number possibility that the a value can be. So if you think about the straight line that passes through the segment AB, there will going to be 8 cases. So first one will going to be the case where it passes through the A, and then you will keep passing through the AB, but then the last one will going to be something that looks like this, and that is also the parallel with the first line. So if you think about what it means by a parallel, That means the parallel size contains the same slope in the function. But same slope, but it should contain a different y-intercept in order to move our function. So there will going to be a same slope, which means all of their function that is beside a and b will going to be y is equal to -1 over 2x. And if you think about what the slope is, the slope will going to be -1 over 2 in this linear function. And the y-intercepts will going to be different. So the a will going to be the y-intercepts, which means it is the output of a function value when our input x value is equal to 0. So first of all, let's think about the first case. You should pass the a, which will going to be the starting line. A, if you think about the coordinate of the a is equal to 0, 4, where our y value is equal to 4. So our a value also always starts with y is equal to -1 over 2x plus 4. Now let's think about the last line. Our last line will going to be the line that passes through the point B, and our point B will going to be a, 4. If you express what the b will going to be, it will going to be a case when our x value, our input of our function, is equal to 8, and our output of our specific function will going to be y, and it is 4. So we could say that only thing that is different in the linear function will going to be the y-intercept, which means same thing with the y-coordinate, and our y-coordinate of this b will also going to be 4. But then if you input the value as 4, it will going to be exactly same with a. So we need to make something different with the a, which will going to be our x value of our quadratic function's coordinate, which will going to be 8. So the second one will going to be y is equal to -1 over 2x plus 8. So the values that passes through the a, b will going to be inside these two quadratic functions. And we could see that 8 will going to be our x coordinates. So beside the 4 and the 8, so beside the number 4 to 8, there will going to be the case where the a value can be stand on. But then, so the 4 to 8 will going to be 5 numbers, and the a can be either 1, 2, 3, 4, 5, 6, 8, since we knew that it is numbered from the regular auxiliary dice. So we can say that the number of possibilities for the a, for a total, will going to be 1 over 8 times 5, which will going to be 5 over 8. So our final answer for this question will going to be 5 over 8 for our number of possibilities for the a. So at first we thought about the two cases of our quadratic function. First we're going to be a when the a value is greater than 0, which means when our leading coefficient is greater than 0, the graph will go upward and it will only contain a minimum point. The second way will going to be when our leading coefficient is negative value, the graph of a quadratic function will open downward and it will contain a maximum point. And if you think about what the y-intercept will going to be when it comes to solving for our a value, a coordinate, it was when the x value, our input of our function, is equal to 0, our y value, which will going to be our output, exists. So we solve for our a value, but then if you think about what the b value was going to be, b value will going to be same with the a values, y coordinate, but then different x-intercept. So we solved it by simply inputting the output of our function back to our original function. So now we thought about what the lengths of our quadratic functions, the coordinate, will going to be. it will going to be the differences between the coordinates, and our two coordinates were going to be a point A and a B. So the only thing that was different between point A and a B was 8, which was our A value. But then there was two number possibilities where it can be either 8 or the negative 8 because it contained a square. So first of all, we thought about it through the realistic question, which means when it comes to solving for the line, we only take it as the positive value. So our segment AB's length was 8. Now we thought about the linear function that passes through our point AB. The starting line should pass the point A, another line should pass the point B. So the differences between them was the y coordinate and the x coordinate, which was y is equal to negative 1 over 2x plus 4 and the y is equal to negative 1 over 2x plus 8. But the same thing between both of them was they contain a same slope, which was negative 1 over 2, which made them parallel. So the A value can be beside 4 to 8, but we could figure out that it is from the oxygen dice regular. So our number of possibilities was from 1 over 8, which was from our dice. And the 5 was from our actual A values that A value can be. And our total number of possibilities of our A value was 5 over 8.